Okay, so now that your block is created, we're going to do our CAM of this block, which is a computer aided manufacturing. So you're going to go up here to design, where it says design up here in the top corner, and you're going to go down to manufacture. All right, brings you up a whole new toolbar here at the top. We're going to be looking on this part, obviously, at the 2D manufacturing. So we're going to click on this, and there's all of these different options on 2D. We are going to do basically 3 that we use often. For a small hole that we have on the sheet, we're going to use a bore. We see here where it says when we hover over the bore, you can see down below there, it shows some of those small holes there on that front face of that object. So this is what a bore is for, is there. Next one that we're going to use is for larger holes. We're going to use a pocket. What a pocket does is a pocket will clear out, as you see by the paths there, clears out all the material entirely for that. So there's no pieces left there in the center of the object when you cut the hole. And you'll see the difference between that when I mentioned here about a contour. So our last thing we're going to do is going to be for your outside path around the object, or for large holes, we're going to use a contour. So what a contour does, it just does one path all the way around the outside of the object, or as you see here, on the small holes all the way around the outside of the small hole. The problem is, or larger hole, the problem is when you do that larger hole and do that one path around the outside, it leaves you with that little disc in the center. On plastic, that little disc in the center sometimes isn't bad, but it can still get jammed in there and it can snap off your cutter. Your cutters are very sharp, they're very hard, but with that they're also very brittle. So if that little piece gets jammed in there, it'll snap off your router bit, and there goes, for an 1/8 inch router bit, there goes about $40, $30 to $40. So instead of that, we do the pocket, which removes all that material. If you're doing large pockets of larger things, you have like say a 2x2 inch hole in the middle of something, then we can do a contour, but we would want to fasten down that piece in the middle so it doesn't come loose. You could possibly put a screw out in the middle of that piece out there in the center of it and screw it down to the table so it doesn't come loose. But you can't just remove and let it lay in there loose. You could also possibly add some tabs to it. We'll talk about tabs later and what that is, but there we go. All right, so there's the 3 different ones we're going to use. We're going to start with our first one, our small hole. And again, what I said on the small hole, that is a bore. So we're going to go over here to bore. Oh, wait, and we're not going to do that first. Yeah, we're not going to do that first. The first thing we're going to do is up here in the top left corner, we're going to do setup. So we're going to click on setup. When you go to setup, this is kind of the most important step, and I almost left it out. When you go to setup, it gives you the little X, Y, and Z coordinate system out here in the middle of your object. What we want is we want the bottom left corner of the object to be the starting position, our 0, 0, 0 position. And the bottom left corner on the top surface of the object. So what we're going to do here is we're going to grab this. We're going to drag, oh no, we're not going to drag and drop. We're just going to click. We're going to click right there. And move that right there to that corner where my X is pointing along in this direction, my Y is pointing up, and my Z is pointing out of that top surface. Now, depends on the orientation you created yours in. It's okay if it ends up being in this corner. You just have to have your X, Y, and your Z turned around. Now, you can adjust this if your X, Y, and Z is not match up on any of those corners. And the way to do that is like so. We're going to click on the shaft of the little X, Y, and Z. And if I wanted to change it to here, that would change the X, Y, and Z so the Z is pointing on that axis. That's not what I wanted, so I'm going to go back to here, click on the shaft again, and click on this corner of the object, and that switched my Z, so where my Z is pointing up. So there is some ways to modify this and move it around, and there's some ways over here to flip on the Z axis, flip on the X axis if it happens to be just opposite of what you need. This gets to be kind of a mess to get to where you want it to line up. But you can fiddle with that, experiment with that, and to move it around. Right now, we're perfect here. Top surface, bottom left corner, X is side to side, Y is up and down, and Z is coming out. So that's perfect for our setup. We're going to go ahead and go OK. All right, now we're going to go ahead and start with our all of our steps here. So first, I'm going to go ahead and do my bore. So I'm going to start with my bore. To do this bore, we're going to rotate our object a little bit so where I can see this bottom surface right here, and click on the bottom surface, click. And all I'm going to do there is I'm going to go ahead and do a few settings. My first setting here is I need to pick my tool. It went to geometry first. I don't like that. I like to go to the tool first, and I like to set up my tool here. Right now there is no tool selected, so I'm going to click on select. Brings you up to this window. They have all kinds of sample tools built into this. So we're going to come over here to the side, sample tools inch. Under sample tools inch, we can narrow this down. We know what the diameter of our tool is. Well, and actually we know another thing. Our tools that we're going to use for this is going to be a flat end mill, so I'm going to select flat end mill. Then on diameter, I'm going to set 1/8. And that narrows me down to where I only have one choice, which is great. 1/8 inch flat end mill. Click and select that. Okay. Now with this, there is some default speeds and feeds and all that. We don't use many of the default feeds and speeds, but we can go ahead and go down through this list. If you didn't have any idea of the feeds and speeds you used, this is a good place to start. And it will cut using these feeds and speeds. We just kind of modified ours to where we know what works really well with our router table. So down through this, we're going to do plastics roughing is what we're going to do. So we're going to select on it, and we're going to go select. All right. So again, that gave me all kinds of things in here. Our speed is 11,991 revolutions per minute. Feed per tooth is 0.01114 whatever inches. You know, all these different things. Now yours may be different. If yours is in here and it's not in inches and it's in millimeters, it's millimeters per minute and things like that, you need to go out and you need to change your drawing. Here underneath the units, you need to make sure this is set to the correct units. It's set to inches. Our router table, if you have it set to millimeters, will error out. It will not work. So you need to make sure on units, make sure you have inches, and that's going to be great there. Mine already was inches, so I'm going to cancel out of there. Now we need to get back into that setup. Oh, I canceled out in the middle of that. All right, I'm going to pause the video and get back to where I just was. Okay, I'm back here to where I was. All right, so the 12,000 inches or RPM on the spindle speed, the ramp speed, both of those are just great. Cutting feed rate, however, we're going to move that up a little bit. Cutting feed rate, our machine does just fine at 80 inches a minute. So we're going to change that up to 80. Lead rate, we're going to change that to 80 also. 80 there also. We're going to change all these. Feed rate, lead in feed rate, lead out feed rate. Ramp, we're going to change that to 80. Now here's one on the plunge, how fast it goes down on your plunge. We are going to actually cut that one down. It's at 26. We're going to take that down to 15. Seems like sometimes that thing plunges really fast. All right, so for this one, for the bore, that's all we need to change. There are some other tabs up here that we'll look at later on some of these other procedures or processes that we're going to do, but not here. So we're just going to go OK. All right, so that's got my first one done. It'll show up here and kind of show you that first little hole. All right, we're going to go back up here to our 2D. This time we're going to do the 2D pocket. Again, very similar to what we did last time on this pocket. We're going to pick the bottom surface of this hole. And there we go. Now, what's kind of nice is, since I set all of my feeds and speeds and all that on that first tool, now it assumes I have the same tool here, and all those things are already changed. It has the 12,000 RPM still, and the 80 inches a minute, the 15 inches of feed rate of the plunge. All those things are already set, and that's great. All right, now on this one, we are going to do some other things on this one. We're going to go over here to our passes tab, and on our passes tab, we're going to come down, and we're going to go down to the stock to leave, and we're going to check on that. Okay, as I started to say there, sorry, I had to pause my video. Somebody came into the room. On the passes tab, you're going to go over there, and on stock to leave. This is one that does this since this is a roughing cut, but we typically use it as our final cut. It has stock to leave, which is 0.02 inches, and that's in the radius. So with that, if you leave 0.02 in there, that means your hole is going to be 0.042 small or smaller than what you called it out. So what we've got to do is just uncheck that stock to leave. We don't want to leave any stock there at all, so it makes our hole the full size. All right, now this next thing I'm going to show you here depends on the thickness of your stock. If you're cutting 1/8 of an inch thick plastic, if you're cutting 1/8 inch thick plastic or less, you can do one pass. So 0.125 or less, you can cut it in one pass. If your stock is 0.125 or over, you have to do multiple passes. And that's going to be here under multiple depths. So if I check on our multiple depths here, right now, remember, I set my material to 0.1 thick, but that just kind of was a preliminary set or thickness. We'll set the actual thickness to our material here as one of our very last steps. So our maximum roughing step down, what we do here is change this to 0.12. So that way you're going to do multiple depths. Each cut is going to be 0.12 deep, and that will be great, and that's going to work awesome there. Once you have all these things set, we're going to go down here and go OK. We can go ahead and shorten that up a little bit if we want to. Go here and do OK. And again, you'll see this will generate it. Notice it comes down and it just spirals down and it does one cut on this, and that's it. Actually, it still does look like it does two cuts. It'll do the first cut on this path or this depth, and the second cut it'll do down here on this depth. All right, so we're good there. Now let's go ahead and do our last piece. You always do your inside parts first, and then you do the outside of it. You want the piece to be held solid in place and do all these interior things before you cut this exterior path. So we're going to go here on 2D. We're going to do a 2D contour. Once again, just as we've done on everything else, you're going to select the bottom surface. And we're going to start going through here. Again, our cutter still has all of our correct settings, so that's great. Next, we're going to go to, and let's do it in the same order as we did before. We're going to come over here and do passes. Same thing on passes. We're going to go multiple depths. If it's over a 0.12 thickness, and we're going to set this to 0.12 for our depth. And this does not have that roughing passes on it. Or sorry, it does not have the roughing. It does have the roughing passes. This does not have the stock to leave on it. So that's good there. We're going to come back now to our geometry tab. On our geometry tab is where we actually add tabs to your piece. Tabs are the little things you see here in the picture that holds it into place so it doesn't wiggle loose while you're cutting around the outside of it. When possible, it's best to design a piece and a part that does not have tabs on it. A lot of you guys are going to be doing battle block parts and different things like that. You always have a lot of screw holes out in the center or bolt holes where things are held down. You do that in one pass, put all the bolt holes in there or all the holes cut into it, and then you just use some screws and screw that part to the table, and then you can do a pass around the outside. This one would not work well with only one hole in it to do that, so that's why we're going to have to do tabs on this. And it's a small part, you wouldn't be able to get screws in there anyway. So we're going to go there to do tabs. The tabs, however, are too small for plastic. It just will not work well. We typically even leave these larger for our metal also. So our tab width, we're going to change to 1/4 inch at 0.25. Tab height, we're going to change to 0.06. All right, so 0.25 and 0.06 for those two. And that is it. There's nothing else we need to change on this. So on this one, we kept our tool set correctly. We made our tabs. We changed our passes to multiple depths. And that's it. You're going to go OK. Oh, wait. No, we're not going to go OK. We didn't place our tabs yet. The tabs here. They're right now at by distance. They're spaced out every 1 inch. I don't love that because it puts tabs in places where we don't really like. We don't want to tab down at the bottom of this curved arc because it's going to be really hard to sand out. We don't have a sander that sands in the bottom of a curved arc very well. So better than at by distance, we're going to go at points. At points, you're just going to click on where you want your tabs to be. So I want a tab to be there. I want one to be there. So 2 on that side. Spin this around. 1 approximately in the middle of this side somewhere there. 1 there. And 1 there. So now I have all those tabs. We're going to go OK. It's going to calculate that. And that looks pretty good. There you can see all my tabs. Here we can actually do a preview of what this looks like. We can simulate it. And we can play through our simulation. You can see what this thing does. Oh, and now here, this is an important step. Notice it's just doing that outside pass, or the outside contour. I'm going to go ahead and stop this. That's because I selected just on the contour here. I want to make sure I select on the setup, and then do my simulation. And now I'll do all of my steps. This is the same thing when you export this to post it and create your post. If you're not selected up here on the setup, it won't do all your steps. It'll just do the one thing you're selected on. So there it goes around, and the time's going to run out before it finishes this, but you can see what it looks like. Good job.